because this is where I have it. But I would suggest whatever I write down up here, you write down on the handout that I gave you, okay? Because you don't get to use your notes during the test, you get to use the handout during the test, okay? So we talked about yesterday there's 3 rules, there are 3 principles for electron configuration. Pauli exclusion principle, Hund's rule, were both about orbital notation, what we did yesterday. And then the last one, the Aufbau principle, is about electron configuration, what we're doing today, okay? So according to the Aufbau principle, electrons occupy the orbitals of lowest energy first. So this is a question that's on the worksheet that I gave you. What is the lowest energy level? And you could have found that in the notes under the principal quantum number n, or we can see that, remember from yesterday, the orbital notation, the number tells you the energy level and the letter tells you the shape or the sublevel. So if 1s is our first thing to fill in, the lowest energy level is 1. Okay? So when we're filling this, you follow the arrows. You don't go horizontal across. You go diagonally down back towards the bottom left every time. Okay? And when you go through an arrow, you go back to the top and you go through it again. Okay? So on your handout, I would definitely write like a start or like put a star or circle or something. Kind of looks ugly, but oh well. That we're always going to start with 1s every single time. And then after 1s, then we would go to the top of the next one and go down to 2s. And then we go to the top and go to 2p and 3s and 3p and 4s and 3d. So you don't go in number order, and that confuses people. You'll get it wrong if you go in number order, because it doesn't always go that way. It does at the beginning, but as you get bigger and bigger, it doesn't. Okay? Then, you know how it was like 1s2, 2s2 in the song? That exponent number tells how many electrons are in that orbital. Okay? So to help us out on our handouts, we're going to write down the maximum number of electrons. So the max electrons that each one holds. Okay? So you might need to look back in your notes, but what's the maximum number of electrons an s orbital can hold? 2. What about a p orbital?
4.
Look back in your notes.
Yes, I don't know.
Look back in your notes. 2p6.
6.
Yep, they can hold 6. What about the d's? 10. And s? 14. So that's why in the song he was singing like 1s2, 2s2, 2p6. That was showing that those orbitals were holding that many electrons. Okay? Some people are going to get it like this, like super, super quick. Some people, it's never going to come that easy. Okay? But before we actually do the examples in your notes, let's look back at that handout that we did over here, and where there's that electron configuration column. We're going to do that first, okay, to show you how it correlates. So I need to like fill this in really quick. I, again, only have like the first 7. That's not supposed to be there. Shoot. Okay. There we go. So that we can see how it works. So electron configuration is really just it's condensing down what we wrote for our orbital notation. Okay. So for hydrogen, we have 1 electron in the 1s. So for the electron configuration of that, it's going to be 1s for the orbital, and since there's 1 arrow, the exponent is going to be a 1. Because the exponents are what we're doing, that's how many electrons we know are in there, okay? Then for helium, we have 2 arrows in the 1s, so that electron configuration is going to be 1s2, okay? So it's really just counting the arrows of what we've already filled out. So if you understand it, you just go for it, okay? But I'm going to keep going. So lithium has 2, so it's going to be 1s2, just like before, but then it has 1 electron in the 2s, it'll be 2s1. Okay, and beryllium is going to be 1s2, 2s2. And boron, 1s2, 2s2. And then we get to the p's, and that confuses people, okay? So even though in your worksheet it has like 2px, 2py, 2pz, the P holds 6 electrons, so they all just combine together for one exponent overall. So for boron, even it's just going to be 2p1 for the n spot. Okay, and then when we get to carbon, it'll be 1s2, 2s2, and then 2p. There's 2 electrons, even though they're not on the same line. It's still going to just end with 2p2. Okay, so it doesn't matter about the x, y, z. It matters total how many. Okay, and then nitrogen, 1s2, 2s2, 2p3. So go ahead and finish all the way the rest of the way down. So again, you should not even have any 3s in the electron configuration until you get to sodium. So this is nice because it just kind of gets us in the hang of what it's going to look like for electron configuration. But if you look at the example that we're going to do next, you don't get the orbital notation first. It would be so much more work to do the orbital notation and then also do the electron configuration. So now we need to know how to do it without doing orbital notation first. Okay? So we're going to go back to the examples in the notes in order to do this, okay? Just before we do this, okay, to refresh your memory, okay, not the big number, but the exponent number tells you how many electrons are in that element, okay? So hydrogen has 1, and it's because of that 1. Helium has 2 electrons, and we know that because of this 2. Lithium has 3 electrons, so it's 2 plus 1 gets us 3, okay? So those exponents are what we count up to know we have a certain number of electrons for the atom, okay? And the way that we know when to stop when we're doing the diagonal is when we get the number of electrons we're supposed to have, okay? And we always go in the same pattern as we go. So let's do the first one. Yes?
So why do we do this since the electrons for the element don't like the numbers of them?
What do you mean? Like, why are we doing all this?
The number of electrons is just the atomic number.
Yes, but
That doesn't.
electron configuration tells you exactly where they're located in the atom. So it's describing where the electrons are located. Yeah, there's 25 electrons, but where are those 25 electrons? And that's what electron configuration tells you. Okay. All right. So the first one we have is K. What is K called? Potassium. Don't get that wrong on the quiz today. And how many electrons does potassium have? 19. So we will be done when we get 19 exponent or 19 in the exponents. Okay. So we always start with 1s2. So that'll be first. So when we write down 1s2, we have 2 out of 19 electrons. We move to the next line. So what comes next? 2s2. And that's a total of 4 electrons. Okay? After 2s2 comes 2p and 6. Now, if you don't know where like the 2, the 2, and the 6 are coming from, that, remember, we wrote down at the bottom the maximum number of electrons. If you move to the next orbital, that means you're putting the maximum number down. Okay? So that maximum we can have for a p orbital is 6 electrons. So after 2p6, what comes next? 3s2. How many electrons is that now? 12. Okay, so we only need 7 more. 3p6 gives us 18. And then 4s, and instead of putting a 2, because we only need 1 more to make 19, then on the end we would put just a 1. Okay? Only the end atomic orbital can have a number other than a 2, a 6, a 10, or a 14. And that's just to make it so that it adds up correctly. Okay? Everywhere else inside should have a 2, a 6, a 10, or a 14. Okay. Let's do another one. So the P, what's P stand for? Phosphorus is preposterous. Yeah. How many electrons for phosphorus? 15? Okay, so that means it's going to be shorter than the potassium was because there's less electrons. Okay, so we start right back at the beginning though. We go back to 1s, so we'll still have 1s2, and then 2s2. That's 4 electrons. 2p6 is 10 electrons. 3s2 is 12 electrons. And so at the end, our last one is going to be 3p as well, right? So, and what's that going to be? 3p? 3 to get it to be counting up to 15. Okay. How many people, raise your hand if you think you're a pro at this? If you're a pro, stop doing the examples and just do the worksheet on the back. Okay? How many people would like me to do the last one with you? One more example? Okay. If you want to keep listening for the one more example, that's fine. If not, just start working on the back side. Don't worry about the back side of the worksheet, the bottom section, that's tomorrow. Okay? So for neon, how many electrons does neon have? 10. And so this one's even going to be shorter than what we had before. So we'll start up at 1s, 2, 2s2, and 2p6 gets us our 10 electrons for neon, so that's where that one ends. Okay? The 3d10, I'll give you a hint. 3d10 is 30 electrons, and there are some on there that you're going to have to do like 80 electrons, just an FYI. So if you thought this was easy, it's going to get difficult. 3d10 gets 30. So if you have to go more than 30 electrons, you're going to have 3d10 on your paper.